What's going on?
I see I had more hair then too. So welcome everyone to OPC Day Finland. Yes, I'm Jim Luth. I'm currently working for Schneider Electric as a architect in R&D, but I do spend most of my time working on standards work, and a lot of that is for the OPC Foundation, where I serve as the CTO, the chair of the UA working group, a member of the Technical Advisory Council and the Technical Control Boards. So if it's technology driven at OPC, I'm there, is basically the way that works. And I've been working with the foundation and for the foundation in various capacities since 1997. So what I'd like to talk about today are essentially two somewhat distinct topics. One is our plans for release of the 1.05 version of OPC UA, and we'll go through what that will entail and how it'll be the same and how it'll be different. And then in future visions, there's lots of things I could talk about, and of course I could talk for hours about different technologies and different things we would do or might do or what the future might hold. But there's one particular one that I wanted to talk about, and that's the UA information model outside of OPC UA. And I'll give some examples of that. And that, with any luck, will take me about 20 minutes. So OPC UA, now we've been doing OPC UA releases for coming on 15 years, I think, in various forms. And the current released version is what we call 1.04. And roughly about every 3 years, we refresh the versions to be complete and in sync, and all bug fixes, improvements, additional functionality are in them. And so we're doing that again for 1.05. So what that entails is we've amassed pages and pages and pages of an errata document that, with corrections and so forth to the 104 version, those all get applied in 105. And also, starting in 1.04, we started to make technical additions, functionality additions during the release without touching the original release documents. And we did that in the form of amendments. And we stole that process from the IEC, which seemed like a good idea at the time because, of course, the OPC UA specifications are also an IEC specification. And the way that works is you write the new functionality in separate documents, and then you say things like, in section 7.4 of document part 3, please add the following paragraph below the figure and blah, blah, blah. So you provide a cookbook of instructions of things that somebody would then logically cut and paste into the 104 release to provide these amendments. So we've amassed quite a number of those, and again, the real work is to simply take all that stuff and put it into a cohesive set of parts. So we're still planning this release to happen starting this year. We are running out of time, but fortunately the parts will be released in batches, and as usual, the first batch is the real core, the meat of OPC UA basis, which is parts 3, 4, 5, 6, and 8, as it turns out. And so that will be, those are the ones that we're focusing on mostly right now in terms of getting them complete in order to do the actual release. So when OPC 105 is finally released, which will take, of course, a good substantial part of 2021, these are the envisioned parts. You see, in the end here, we're going to have 22 parts that will be comprised of 105. So for those that were following along, most of you will recognize things through part 14. They were the original conceived 104 version, where we added part 14, which was pub sub, of course, a large undertaking. And since the original version of 104 was released, we've released a number of amendments that added functionality, and we've even released some parts, right? We released part 15, safety, as part of 104. We've released part 17, alias names, as part of 104. So we've been adding functionality all along in forms of other parts and in form of amendments. So all of the amendments that are part of 104 right now will go away. They'll be folded into one or more of these 22 parts. And we're doing some other housekeeping and rearranging of existing data. So you'll notice that we have, as an example, a new part 16 called state machines. This really is not new functionality. This is a combination of Annex B from part 5, which was called No Surprise State Machines, and then plus the enhancements to state machines, which was Amendment 2. So we're using the opportunity to create a cohesive set to actually move some functionality around. So don't be surprised when you go looking for things and they're not quite where they were in the past. So one of the things about our versions, and again, as much as it's a big deal to us, and we spend a lot of time trying to get everything correct and right in these documents, from a software point of view, the versions almost don't matter. In fact, the original 1.01 version of OPC UA is still completely compatible with the 104 and will be with the 105 version. So, you can literally take a client that was written many years ago and connect that to a server that's brand new in 104, and it will do all the things it knows how to do based on the versions. And the reverse is true too. I can take a 104 client and connect it to a much older server, and the functionality all still works. So one of the things that I'm quite proud of from OPC is that we've managed not to make any significant blunders that would cause us to have to do a release like a 2.0, right? And you notice that it's all still 1.x version because everything is compatible. And that has certainly been a boon to the acceptance of OPC UA. No one likes to be on that treadmill where the developers of the spec make changes left and right so that everybody is constantly scrambling. And we pretty much managed to avoid that. So as we do the 105 release and everything is all nice and tidy and there are no erratas because the specs are perfect and there are no new functionality in forms of amendments, one of the things we're going to take this opportunity to do is to revise actually our release process and how we're going to deliver the functionality going forward. So we've made the decision, although we were trying to follow the IEC rules for producing errata and amendment documents and not touching the physical specs themselves, we've found that that's, first of all, it's a lot of work to keep track of the linear drafts and separate amendments and erratas and getting all the pieces right and consistent. And also, hopefully you've by now found out that we have the equivalent of all of the OPC specifications online now in what we call the UA online reference. And the online reference is a huge advantage because, of course, all the linking between parts and the ability to do Google searches on keywords and named objects and things like that is huge. Certainly a much nicer facility for sort of finding things than digging out PDF files and plowing through them and doing separate searches. So with the online reference, we've had a difficult time trying to keep stuff in sync with all the errata and amendments and things that would likely would need to be applied to the online version, which is supposed to be the best and up-to-date version. So what we're doing is we're eliminating errata and amendments themselves. And what you'll see is we're not changing how often we release the functionality or the fixes, what we're doing is we'll be updating the parts and the drafts directly as needed as those things happen. So again, typically every few months, we're releasing an errata with just bug fixes and or with new functionality. And this you'll start to see by seeing, a 1.05.1 and 1.05.2.3.4.5, whatever, for the parts as they're needed as they go along. And of course, that released, updated point release version of the document will be exactly what's placed in the online reference, and the text will match exactly all the time. So hopefully this will be easier for everyone. It will take a little bit of getting used to, and that instead of, part 4 changing once every 3 years, it could change once every 2 months. But the logic here is that we're not changing how often we're making changes or fixes. We're simply changing the delivery mechanism of those fixes to just have the document versions themselves. And so completely eliminating the publication of separate errata and separate amendment docs. Because people like to see, the advantage of the errata amendment docs is it's easy to see just the changes. And what you'll find is that we will end up producing a sort of a better change log in the documents themselves to make, again, to give you that ability to, if you knew what the last version was, you'll be able to figure out what's changed between the 2 point versions. Okay, so that's all I have on the 105 release. Like I said, there isn't a lot of, per se, new functionality out the gate, at least. Of course, 105 will itself evolve and more functionality be added over time, but it's really the coalescing of all of the new functionality and that happened over 104 and rationalizing it and putting it into proper parts and applying the errata and so forth. So now the fun stuff. What I really want to talk about is this one aspect of OPC UA that's become interesting to me, and to see how our thinking has evolved on some of this. As you all know, the UA information model aspects of OPC UA are very powerful, and we've been advocating for much time that building all this metadata into the model about the data is key to OPC UA and very useful. And we're finding a lot of places where this type of modeling is becoming more and more popular. And of course, we often go in and say, well, you should just use OPC UA for that. And people do, but sometimes it's not practical. And so what we're working on at this point is a number of different ways where we intend to provide the UA information model, but provide it in a form outside of OPC UA. And so there's 4 particular use cases that I'll go through and talk about how we're using the UA information model outside of OPC UA. So the first example is the case for offline engineering. So in a complex plant, a lot of design work happens before anyone has bought physical hardware, PLCs, controllers, MES systems, and the like. And so there is no software to run an OPC UA server or client to render an OPC UA information model. And yet there's a need to do design work around those information models. So as an example of that, FLC, which is OPC's field level communication initiative to create the next generation field communication and field bus functionality, is using a technology called automation ML as its offline engineering exchange format. And essentially, this exchange format was designed specifically for sharing of engineering data among different design tools throughout the automation lifecycle. So their focus from the get-go has been on this case of offline engineering, whereas OPC UA's focus has been in the online information sharing of those types of information models. So what we've done is we've created a utility that will convert node set files from OPC UA into automation ML libraries so that the features of OPC UA can be modeled in an offline tool. And what this looks like, this is the free automation ML example editor from the automation ML organization. And here you can see, you might recognize some of the things in the different panes here in the form of different libraries. And I'm not, of course, going to go through the details of how to build all this stuff with the automation ML editor, but it's interesting to see the OPC UA information model in action in the tool completely outside of OPC UA. And so the FLC offline device descriptions and offline configuration work will be done in tools that use this technology. Certainly not this editor. It's not appropriate for end users, but the XML technology behind it will be used in the libraries. Okay. So another example of using OPC UA information model in a different form, we have a working group, a subgroup called semantic validation that's working on tools that will prove or disprove a information model conforms to a set of rules that are presumably in the specifications about that model. And this is an interesting work to tighten up our ability to do compliance testing and write accurate specs and use sort of computer language to describe shalls and musts in specs as opposed to the English language we use now. And that group made the effort to convert UA information models, again, from the node set files, into OWL, the web ontology language. And the reason they did this, to, again, change the format of the information model, was it allows standard tools to be used from the ontology world to validate the graph-based data that is OPC UA. In this example, Shackle, which is a shapes constraint language for OWL, was used to validate the form of the OPC UA information model. So very interesting use of translating a UA information model outside of OPC UA. So a third example of where we're extending the UA information model outside of UA interfaces is our own cloud library joint working group with SESME. This working group is working on a way to store and publish and provide OPC UA information models in the cloud effectively. And again, store them in standard cloud-based databases. So again, in this case, even though the information model is OPC UA, the goal is to make these things more useful with the IT tools used in that environment. So JSON payloads, graph-based query languages like Sparkle and Gremlin, and maybe eventually a natural query language are all possible. But again, not using a UA interface, but using the information model that's described in the UA node sets. And the last example I have is upcoming work and future work that's being done around the Industry 4.0 asset administration shell, where again there's a long life cycle of goal of having the asset administration shell be useful long before there are physical representations and digital representations of objects. And OPC UA plays a big role here in the certainly in the operations side when there are running OPC UA servers, but that same information needs to be available in different forms and in different ways at different ends of the ends of the spectrum here. And again, you see automation ML come up here again as a viable technology, and as well as XML and JSON. So we're seeing a lot of people appreciate and value the OPC UA information model, but realize that they want ways to represent that and use it outside of strictly outside of OPC UA. So that's what I'll leave you with today. That the world is bigger than just OPC UA, but the value of the OPC UA information model will extend well outside of OPC UA and will float the, will extend the reach and the adoption of OPC UA by the fact that it's all connected, whether you're directly in OPC UA or you're simply using a UA information model from UA somewhere else. Okay. So I think I'm out of time.
Yeah, thanks, Jim, but it's not because of you. You had to start 5 minutes.
Yeah, that's fine. Yeah,
you made it in time.
usually good at making up the time, right?
Yeah.